So this lab is for build VPC and launch a web server. In this lab, we will use Amazon Virtual Private Cloud VPC to create our own VPC and add additional components to produce a customized network. We will also create a security group. We will then configure and customize an EC2 instance to run a web server, and we will launch the EC2 instance to run in a subnet in the VPC. Like so Amazon Virtual Private Cloud, Amazon VPC enables to launch Amazon Web Services, AWS resources into a virtual network that we define. This virtual network closely reassembles a traditional network that we would operate in our own data center. With the benefits of using the scalable infrastructure of AWS, we can create a VPC that spans multiple availability zones. So if we can see the picture, this is the AWS cloud. This is the region. In this region, there is two availability zone, zone 1 and zone B, zone A and zone B. Here we will create one VPC. Within this VPC, we'll create subnets like public subnet 1, private subnet private 1, and public 2, subnet public 2, subnet private 2. And within this one, this is NAT gateway. NAT gateway is the gateway. It will connect to the internet gateway. This in using this gateway, the outbound traffic is can go out, but vice versa is not possible. So this is the public route table. Destination is 10.0.0. /16, target local, and destination 0.0.0.0/0 internet gateway. And this is network gateway, target is local, both target is local. But for the public one, the target is internet gateway, and the public route, the private route table, the uh, target is NAT gateway. So after completing this lab, we will be able to create a VPC, create subnets, configuring a security group, launch an EC2 instance into a VPC. So now we will create a VPC. Here we will type VPC. This is the VPC. Mm, The region is not Virginia. Not Virginia, US East 1. So we'll create a PPC. So we'll go to the PPC and more. Name tag and local generation clicked. So the CLTR block is availability zone 1, number of subnet 1, public subnet 1, number of private subnet 1, customize the subnet block, and the private one should be 1. NAT gateway 1 AZ VPC VPC equals to none. Keep DNS option enable DNS hostname and DNS resolution. In the preview, we can see VPC. So we will type it lab VPC. So here in the lab. Okay, so here preview. This is a lab VPC. Public subnet public subnet the VPC. The public subnet name is one. Private subnet name. Route tables. Lab RAB public. Private EVS is 1. And network connection, lab internet gateway, and lab NAT is 1. Okay, fine. Now everything is good. We can create the VPC. Okay, so and this should be 24 and this should be also 24. Okay, create VPC. It will take time to create the VPC. So we need to wait until all the resources are created. That's why we're waiting. So it shows success. Our VPC is created. So view the VPC. This is the VPC. So this VPC with provisioned this VPC with a public subnet and private subnet in one availability zone with route tables for each subnet. It also created an internet gateway and NAT gateway. So if we can go to the subnets, this is one of our subnet. Table. There is the route details. This is local and this is internet gateway, like internet gateway, this one, public route table. An internet gateway is a VPC resource that allows communication between EC2 instances in our VPC and the internet. The lab subnet public 1 US East 1, a public subnet that has CIDR of 10.0.0.0/24, which means that it contains all IP addresses starting at that fact table associated public subnet 00 network traffic to the internet gateway is what makes the public subnet. Now we will create an additional subnet. So we'll go to the subnets. This is private subnet, this is public subnet. VPC, lab VPC. Subnet name. Lab subnet. Public 2. Then availability zone. dot zero dot two dot zero enter. Now click submit. Lab subnet private to availability zone 1 B CLDI block 10 dot 3 critical. Now create subnet. Subnet is created. So we are created two more subnets. One is public, one is private. Now we will configure this new private subnet to route internet-bound traffic to the NAT gateway so that resources in the second private subnet are able to connect to the internet. This one. We create this subnet now, public and private. So keeping this just a private, this is done by configuring a route table. A route table contains a set of rules called routes that are used to determine, like here, route tables. If we can go to this one, there is routes. So here, used to determine where network traffic is directed. Each subnet in a VPC must be associated with a route table. The route table controls routing for the subnet. So we'll go to the route table. So select this one, private one, routes. The destination is 0.0.0.0/0 to target the NAT gateway. This means traffic distinct from the internet will be sent to the NAT gateway. The NAT gateway will then forward the traffic to the internet. This route table is therefore being used to route traffic from private subnet. Now we'll go to the subnet association. We created this route table in task 1 when we choose to create a VPC and multiple resources in the VPC. This action also created left subnet private one and associated that subnet with this route table. Now we have created another private subnet, a lab subnet private 2. We'll associate this route table with that subnet as well. In this explicit subnet association panel, so edit subnet association, we will edit subnet association. We'll create private subnet list 1 and private lab subnet private 2 with this route table. So save association. Now public, the same thing, routes. It will go to for this public route table. Destination is the 0.0.0.0/0 target internet gateway. So now subnet association, edit subnet association. So here, this one is public 1 and this is public 2. Save association. So do now we will create the security groups. Uh, the VPC security groups which acts as virtual firewall. When you launch an instance, we associate one or more security groups with the instance. We can add rules to each security group that allow traffic to or from its associated instances. Create the security group. With web security group description enable HTTP access and VPC is lab VPC. Inbound add role. Inbound role HTTP source anywhere IPv4 description permit web request. So it creates the security group. Description permit web request. The security group name web security group. Now we will launch a web server instance. We will launch an Amazon EC2 instance into the new VPC. We'll configure the instance to act as a web server. For this task, we'll go to EC2 instances. Launch instance. Mm, Name web server 1. When we name our instance, AWS creates a tag and associates it with the instance. A tag is a key value pair. The key for this pair is name, and the value of the name is name entered to our EC2 instance. So now I will choose the I AMI image, Amazon Linux selected. So here Amazon Linux 2023 AMI, this is selected. Now I will select the instant type T2 micro. Yes, selected. There is so many options. So I will select T2 micro. The key pair, we can create the key pair, but now I will select the key. Network setting, we will edit the network setting. VPC, we'll select the lab VPC. Subnet, we'll select the subnet public. Public to auto assign public IP. We'll enable this one. Announce existing security group. We'll take the web security group. The advanced data spam. Here in the user data box, this script will run with root user permission on the guest operating system of the instance. It will run automatically when the instance launches for the first time. The script installs a web server, a database, a PHP libraries, and then it downloads and installs a PHP web application on the web server. So we launch the instances. And this message is success. Now we'll view all the instances. This is initializing. It will not created totally. Takes some time. So now this web server is created. So this is public DNS for this web server one. I can copy this one and paste it in the new browser. Yes, it shows the instances, zone, and CPU load. So it is successfully deployed. So thank you so much. This is today's lab. Thank you.